So these are your 2-5 notes. It's on fixed and variable expenses. You've kind of gone over this a little bit before. But instead, today you're going to create, graph, and interpret the expense function. You're going to do the same thing for the revenue function. You're going to identify the points of intersection of the expense and revenue function, so where they meet. Then you're going to find break-even points and explain them in context of the problem. So just kind of put words with them so that they know what it actually means. Alright, so for your vocabulary, your first word is nonlinear functions. All you really need to know for nonlinear functions, that there are functions when you graph these, it's not a straight line. For this section, you need to know that revenue is usually a nonlinear function. Okay? And it's a nonlinear function when it's in terms of price. So when you're talking about price and revenue, how much money you're bringing in, it's not linear anymore. A second degree equation is anything that has a squared in it. So normally what you would see would be like an x squared. That's what you would, like something like that. That's a second degree equation. When they say degree, they're talking about that exponent. So second, it has an exponent of 2. These are called quadratics. You'll see that below. And when you graph them, you get a parabola. Okay. So quadratic equation is the same thing that we just talked about up above, but you do need to know that there's kind of like a standard way that we write those. And here is what it should look like. So it's y equals, it's going to be ax squared, and that a is just a number. They'll put a number in there. Sometimes it's a 1, but plus bx plus c. And of course those signs can change, but that is just the standard form of a quadratic equation. A parabola is the shape of a graph. So it's like a curve, it's like a U. That's a parabola. If you had one kind of flipped, and I don't know if they have one in here to kind of see, I'll check. You would flip it as well. They have union marks. Like, did you see this one? It would kind of look like that, right? The parabola is just that curvy U. Okay. Leading coefficient. If you're talking about a quadratic function, your leading coefficient is the number in front of your x squared. I'm just going to steal this one. Alright, your x squared leads that quadratic equation. The leading coefficient is just the number in front of it. If it's in standard form like this, your leading coefficient will be the a. Something you need to know about the a, if a is positive, if I can spell, I'm sorry, then your parabola opens up. If it's negative, it opens, oh my goodness, opens down. I'll show you examples of that in just one second. So a maximum value is the vertex of the parabola. When it opens down. And I'll show you a picture of that in just a second as well. Your vertex of your parabola is kind of where everything changes. Oh, I'm sorry. Can I go back here for just one second? I forget one thing. In context of what we're talking about, it's the price where the revenue is maximized, so when it's at its most. So if you were owning a business, that would be helpful because you'd be bringing in as much money as possible. The vertex of the parabola is your max or min, depending on if it's open up or down. And it's where the change happens. So if you're talking about revenue, it's where all of a sudden, instead of making more and more money, all of a sudden you're making less and less money. The axis of symmetry, and there's pictures of all of this later on in your notes, and we'll talk about it. The axis of symmetry is a vertical line that can be drawn through the vertex. Okay, so here's kind of pictures of everything. Here's your parabola. There's the maximum. If this was flipped, it would be a minimum. Your axis of symmetry goes right down through the center, and there's your vertex. That maximum is your vertex. There's your standard form, and this formula will help you find the axis of symmetry if you need to. If A is negative, it opens down. If A is positive, it opens up. Alright, so for your examples, example 1 says, particular item in the Picasso paints product line costs $7 each to manufacture. The fixed costs are $28,000. The demand function is Q equals negative 500p plus 30,000, where Q is the quantity the public will buy given the price P. Graph the expense function in terms of price on the coordinate plane. The actual graphing, you can have the calculator do. That's not a big deal. The first thing you need to worry about is writing an equation that you can actually put into the calculator. So they want the expense function, so we have to make an expense function, and then they want it in terms of price. Honestly, let's kind of deal with that after we've made the expense function. So the expense function, if you remember, expense functions are going to be your variable expenses, so how much it costs each, so $7 each to manufacture. And I need to multiply that by the quantity I'm going to make. And then I need to add the fixed costs, the fixed expenses. So those are $28,000. So I've just made an expense function. What's different, why I'm not done yet, is because they want it in terms of price. Price is represented by P. Right now we have expense in terms of Q. If you look here, they've given us an equation for the demand. They've given us an equation where I can take out a Q and put all of this in. But luckily all of this has a P in it, and that's what I'm trying to do. I'm trying to put it in terms of P. So I'm going to rewrite this equation, the expense equation, but when I get to the Q, I'm going to substitute another equation for Q, so I don't have Q's in my function anymore. So I'm going to put negative 500p plus 30,000. Oops, sorry, I'm hitting the button. Plus 30,000. That's what Q equals. I took that Q out, it's gone now. This red stuff is there instead. And I'm just going to write the rest of the expense equation. Plus 2800. Okay? And I'm just going to go and solve this. So I'll distribute the 7. So E is going to equal negative, that'll be 35, right? 7 times 5, and then put the 2 zeros, so 3,500. There's a P there. And then 7 times 30,000. So 7 times 3 will get me a 21. Bring down those 3 zeros. And then bring down the 28,000 from above. I don't need to distribute the 7 there because I'm only distributing the 7 to the things in parentheses. I need to combine like terms. So this 21 and this 28 will have to go together. So I have expense equals negative 3,500. I'm sorry, that above looks like a 6. That should be a 0. P. And then 21 and 28 will get me 49. I'm just kind of looking at my math because I'm scared I made a mistake. Make sure my zeros are okay. Up here, right here actually, I dropped a 0, which means I should have another 0 here. I'm sorry about that. So this is gone, so it's 210,000. So this will change it to, get rid of that 4, 238,000. So now that you have that equation, all you need to do is put it into Desmos. So I've already done that, but one change you do need to make is Desmos won't recognize the E and the P. So when you go to Desmos, make this a Y and this an X. Y will always be the one over here by itself. X will be in the equation. So if you go and look at what I have before, sorry, I'm going to get rid of all of that. There's my equation, right? And I just put it into the calculator. Sure, I didn't mess up my zeros this time. One problem is, though, if you'll notice, you don't have, you can't even see the graph. What's happening is your y-intercept is 238,000. So you're going to have to zoom out for a really long time. You can keep hitting this button if you want to. Another way that you can do it is go to graph settings. Your y-intercept, it needs to start a little bit before this. So I'm going to say I'd like it to start at 230,000. And then this, of course, will definitely need to be changed, right? Let's make it, I don't know, let's make it 300,000. And now let's see what happens. So finally I can kind of see this graph a little bit. I'm going to zoom out a little bit more. Okay, and this is a linear graph, so there it is. Alright, so your next one, oh, and I'm sorry, when you do these for homework, if you just want to do a screen capture of that, I'm fine with that. Alright, so, I'm sorry. And next one. It's going to be the same thing. I'll just kind of move it around so we have room to see it. So you're going to do the same exact thing. I'll just kind of substitute things in. So it's wants you to graph the expense function. Now I want you to write the expense function in terms of Q, and then graph it. So if it's just asking in terms of Q, our life might be a little bit easier. Let's see. So if I'm doing expense function, it's my variable expenses times how many I'm making. So each earphone costs $5. So my variable expense is $5 times the quantity, how many I'm making, and my fixed costs are $20,000. So if I have my demand function right there, it says write the, the terms of Q, and I'm wondering, I think that was a misprint on my fault. That's my fault. That should be in terms of P. So we have to flip it through. Alright, so there's what Q equals, and I'll do just like we did before, and I'll just put that right there for Q. So keep your 5, and instead of Q, I'm going to put negative 200p plus 40,000. And then just write the rest of the equation, so plus another 20,000. Oops, sorry, I keep hitting that button. So I'll just simplify this. I'll multiply everything by 5. So I get negative 1,000 p. And then 5 times 4 will get me a 20. And add all of those zeros. As long as your teacher didn't mess up, right? Okay, what's another 20,000? Combine these that don't have p's. Oh gosh, that's supposed to be a comma 0. So your expenses are going to equal negative 1,000 p. And then 200,000 and 20,000 will get me 220,000. Again, don't forget when you go to put it in Desmos, change your E to a Y, change your P to an X, and then just kind of zoom out so you can see it, and screen capture that, and you're all set. Okay, so moving on to the next example, example 2. So on example 2, they want to know what the revenue equation Picasso paint products will be. So Picasso paint products, I don't know if you remember, was in the first example. You need to remember that when you're doing revenue, revenue is how much money you're bringing in. Not how much money you're making after you've paid everything, just how much you're bringing in. So to find revenue, you're going to take the price that you're selling at, and you're going to multiply it by how many things you've sold. Okay, so if you're selling, what were they, earphones above for $5, it'll just be like 5 times 2 earphones were sold, so you made $10 that day. I want you to write the revenue equation in terms of price. So again, they want this Q to be gone. They want just P. So if you remember from example 1, they gave you a demand function. This is the same idea. Instead of a Q, I'm going to put what they have above for the demand function. And they had negative 500 P plus 30,000. So I'm just copying that from example 1. All you have to do is distribute the P. Remember when you there's like a 1 here, right? So I'm going to keep the negative 500. But P times P gives me P squared. I'm going to keep the 30,000. When I distribute that P, it's going to be 30,000 P. So kind of take note here. This one changed to a second degree, right? It's a quadratic now. It's not going to be a line anymore. It's going to be a parabola. This is determined, oh, I'm sorry, and this is your final answer. You're done. You don't have to do anything else. Hopefully your circle is prettier than mine. Okay, determine the revenue if the price per item is $25. All you're going to do here is put a 25 there and a 25 here. So revenue equals negative 500, 25 for the P. Remember you're squaring that. Remember you also have to do exponents first. So I'm going to do 25 squared before I multiply it by the negative 500. Plus 30,000. Instead of a P, I'm putting 25. Okay? So when you do all of this out, you're going to get 625 here. Multiply it by the negative 500. Write that number down. And then do 30,000 times 25. Write that number down. When you're all said and done, you should get 437,500. So you would bring in $437,500, if you set the price at $25. Alright, so your next one, graphing the revenue function. So if they want you to graph that revenue equation that you have above in terms of the price, you already have it. So all you have to do here is put it into Desmos. I'm going to copy what we had above. We had revenue equals negative 500 P squared plus 30,000 P. Remember, if you're going to put it into Desmos, which you need to here, this is going to be a Y, this is going to be an X squared, this will be an X. And just put that into Desmos and you're good. Here it says determine the revenue if the price per item is set at $25. If you remember, you just did that. You can do it on the graph if you want to, but in my opinion, it's really hard to see on Desmos. You just did this algebraically. I'm just going to take the answer. If you want to do it algebraically, I'm fine with that. You get a more exact answer. Okay? Did that in the same spot. That's why it's the same question. Yeah. Use the graph in example 3. Which price would get you the higher revenue? So if you're looking at 28 and 40, 28 is going to be closer to your vertex, and that will get you the highest, right? Your graph is going to kind of look like this on Desmos. Here's your vertex. That's where your revenue is the biggest. 28 is here, whereas 40 is like down here somewhere. So 28 will get you the more revenue because it's close to your vertex. It's higher up. Alright, so the next one, they just want you to kind of interpret the graph. Sorry, I want to make sure you can see it all. So I just want to know what's happening at A and at B. Alright, so for A and B, they're both break-even points. Right, your break-even point is where those two things equal. A and B are both break-even points. What you need to know, though, is if you're going before A, right, over here, your expenses, because this is your expense equation, your expenses, this is your expenses, that's your revenue. I'm reading this wrong, right? Your revenue is the parabola. Your expenses are higher than your revenue. That's your revenue. Between A and B, your revenue is higher than your expenses, right? So you have a profit. After B, it flip-flops again. Your expenses are higher than your revenue. You're at a loss. So this is a loss, this is a profit, this is a loss again. So down here they say, why is using the prices of $7.50? I should have moved down more. $7.50 and $61, not in the best interest of the company. So if you look at where $7.50 lands, $7.50 would be on this side. So at $7.50, your revenue is less than your expenses. If you're bringing in less money than you're spending, you're operating at a loss. At $61, it's the same thing. So on both of these, you would be operating at a loss. So your revenue is less than your expenses. You would be operating at a loss. That's why it's not a good interest of the company, right? You want to be in the profit section. Okay, so your homework is page 90, 2, and 3. If you have questions, let me know.